Okay, maybe for the time being, we'll quickly.
I found your updated slide.
Okay. You can let me try to share one last time. If not, you can share Satoru-san.
Right.
Okay, I think it's still first. Do you mind sharing it actually? Or I can skip fast. I think I can.
Okay, I will try to share.
No, I'll share the local version. That's fine actually. No, it's not a line. Okay, thank you so much. Okay, maybe we should get started. John, we can get started.
Yeah, I think it looks good here, and let me know if you need any.
Okay, Satoru-san, should we start?
Yes, please.
Okay, folks, welcome to IETF 125 DMM working group. My name is Sri Gundavalli. I work for Cisco with my co-chair, Satoru-san.
Satoru Matsushima from SoftBank.
And we have John John K for helping us for locally chairing the session. John, thank you so much.
You're welcome.
Okay, next slide, please. Okay, please please read the note-well statement. By participating in the IETF, you agree to the IETF processes and policies. This note-well is a reminder or some of these policies. Please go through this. There's some rules on how you conduct in these meetings. In this, your participation has to be bound by those rules. If you disagree, you have to leave the meeting or disconnect the call. Next slide, please. Okay, we need a note taker. Any help? John, can you ask someone on the...
Yeah, sure. Thanks, Ray. I did talk to Louis, and Louis has agreed to take notes for us today.
Louis, thank you so much.
Thank you very much.
Thank you so much. Okay, agenda link. Satoru-san has put in the link. Please see here. And these are the working group documents, I think. Yeah, please, previous slide, actually. I think just let's do a quick review of where we are. One is the mobility aware transport network slicing for 5G. Satoru-san, you want to say a few words about this?
From my side, the update regarding the working group draft is not just on slide, but the commercial deployment may happen on the our SoftBank network. One of the major mobile operator in Japan successfully deployed the SRP6 map. So that's the update on the DMM.
I was asking about sorry, apologies, Satoru-san. I was asking about the first document. I think is mobility aware transport network slicing for 5G.
Okay, great. Yeah.
Yeah.
The mobility aware transport network now in the status of the published request. So the AD into AD will review the draft and then to be sent to a IESG soon.
Okay. Thank you. So John and authors, we assume you guys will be tracking this IESG comments and closing them. Any discussed comments?
Yes, we will.
Okay. I think first there's a AD review and then it will go. I think first AD review will come. I think next architecture discussions on a service 6 mobile user plane. Satoru-san, any thoughts, comments?
Yep. The order of the SRV map related draft be updated with my previous comment. Commercial deployment be happen, but in the draft, the major text update is doesn't made so far. But next IETF meeting we will have.
Okay, on the SRH, I think this draft has expired. I think. Okay.
Yep. The same thing happened. Same thing for the SRH reduction for SRH with
Thank,
GTP6E. Yes.
thank you, Satoru-san. Mobile traffic steering, we have a update presentation from Marco Levish, so we'll hopefully get to that. Next slide, please. I think there are a couple of other discussions on the two documents, the split document and individual drafts. There's some new proposal on LEO satellites. We are going to hear presentation, I believe, today. I think this is all we have on the agenda. If anyone have questions, comments, anything that you'd like to add, delete, any comments?
Sorry, a quick question on the UDP tunnel ACAS, which is with for which Satoru-san has issued the working group call.
Okay.
Do we need to present that? I mean, I did submit the slides just in case. But
Satoru-san, what's your thoughts?
Yeah, I see your slide. So I think it'd be good to have your presentation
okay,
to make sure the other potential call be succeed or not.
okay, thank you. Sure.
So John, we'll go with the working group document, Marcos, followed by yours or the Union House document. Yeah. Okay.
Sure.
Sure. Okay. Okay. With that, we close this agenda. We go to the first presentation. Marco is locally present or on site.
Yeah, Marco is here. I can see him. So.
Okay. Marco can. Okay. Okay.
They'll control. They'll control unless you want to. I think you need to be a bit closer. Maybe raise the mic.
Now it should work. Now it works. Okay. All right. Mobile traffic steering. So this work has been adopted as working group draft end of last year, and we currently talk about first revision of the draft, the working group draft. And
Marco, slightly closer to the microphone, please.
okay,
Slightly closer.
better?
Yeah, better. Much better. Yeah.
All right. And to proceed and close that work in the near future, there are a couple of things that we need to converge and discuss with the working groups. Next slide, please. All right. Before the one before. Okay. Quick recap on this work. So the draft actually specifies a clear API to extend mobile communication systems towards the transport network in order to enable end-to-end traffic steering. The reason to do that is that today mobile communication systems are not end-to-end, full stop. So as investigated and also described in the draft, we have various use cases that today and also in the near future require such kind of steering, because network operation, flow management will be way more agile as in today's network. So we grayed out a little bit the past history on that. Still, you can read it. Important is version 4 has been discussed at last IETF in Montreal. And it covers major review comments, including the ones from John. And based on version 4, that draft has been adopted in December, resulting from a working group adoption call. Next slide, please. All right. So from version 4, we published version 00 for the DMM working group draft in December. In February, we published the first revision of that draft, also capturing Carlos Bena's comments, which we received during last IETF. So it addresses further comments, mainly also editorial clarification wise. So we moved a bit the reference architecture picture to have it more in a section that the first time refers to it. We added a figure to the use case on node ephemerality, mainly on non-terrestrial networks, which was one of the cases described here. There were a few things that we depicted, though the draft doesn't focus much on it, which was a user data plane interface in the mobile communication system and in the transport network. So we clarified a little bit or added more clarifying text to that. And also on the routing interface that we exemplarily depicted in the figure in section 6.3, and also applied some editorial bits. So next slide, please. All right, that's the current draft structure. We think it's pretty concise and self-contained, and there are a few things in particular in the later parts and sections of the draft that we want to further evolve and discuss with you to have a close, let's say, status of the draft in a mature state. And as you see, we talk about a reference architecture, just to have a picture about what is the system that the draft applies to, and what is the interfaces that the draft focuses on and provides specification. So we have in section 4 a couple of use cases. And section 5, we mainly discuss two different architectural deployment options, which is mainly a dedicated controller and alternatively a decentralized control plane. Then section 6, we discuss, based on these deployment options, 3 different modes how to operate the whole thing, either with a dedicated control plane, decentralized, or in a hybrid approach. So the section 6 is mainly about who talks to whom to enable traffic steering. This is in the proactive, reactive way. So we discuss the different cases just to understand how the later discussed information model applies here. And currently we have a draft version of an information model in the appendix. That's something that needs to be worked on a bit more, and that's what we want to discuss today and in the next days. So next slide, please. All right, reference end-to-end architecture on the top. You see there is a mobile user connected to a mobile communication system, MCS, and the mobile user talks to a service provided by a data network. In between, there is a transport network. Below, we showed that we want to be as flexible as possible in terms of any kind of constellations of user plane anchors, UPAs in mobile communication system, data plane nodes in the transport network, and data network side kind of operation. Next slide, please. All right, just to depict the main interface that draft focuses on. So we show forwarding plane, but want to be flexible here, which kind of forwarding plane is being used. But mainly this API that we specify between the access points C1 and C2 is control plane mobile traffic steering, CMTS. And that's what we focus on. In the above picture, you see it applies between the 2 dedicated controllers, one in the mobile control plane, mobile communication system control plane, the other one in the transport network as an MTS controller. Below, we also discuss the option of a decentralized approach. And here the API applies between data plane nodes and the user plane anchor. Next slide, please. All right. The plan and open discussion points are as follows. So we think the draft is pretty mature in its core part regarding use cases, deployment options, architectural aspects. There may be more description needed on operational aspects. Here we would like to ask you to provide feedback if you want to have more detailed description, different cases covered. Of course, some editorial manicure, and I think these are leftover general comments from John's review, that we sometimes use terms like flexible deployment, dynamic reconfigurability, which requires a little bit more definition what we mean with that. So it seems to be broad terminology. For some people, it may not be clear. So here we want to have a second look at it and try to clarify things. Security consideration, now that the operational aspects API seems to be pretty mature and confirmed, we would like to investigate input for that section. And information model, that's something how we want to make now a proposal how to work on it and proceed to have it in the next weeks and months well concluded. And then there was a discussion about shall this draft, even though it tries to abstract from a particular mobile communication system, have an application example, in particular since 3GPP currently discusses and has adopted studies on user plane evolution for their next generations. So it could be an option to discuss how that draft applies to that discussion and the current architectural directions in the SDO that takes care about the evolution of mobile communication systems. So currently we have a easy picture in the appendix. There are different opinions if that draft should describe this or should be silent about it, right? So we really have different views here. That's something we need to decide. It's easy to describe in the appendix and may be appreciated information. We also talked to some 3GPP delegates, and this is still not decided yet. Okay, next slide, please. All right, information models. So the appendix currently has a rough picture of tables, representation of information that we want to manage in the view of the operational aspects as the draft covers. It's a bit confusing to progress this only on tables. So as a working proposal, we decided and started with an ERD you see it here. There are different representations, and for the cardinality, we decided to apply a crossfoot kind of picture here. And this is just a starting point, and this needs to be evolved in terms of information elements, attributes that need to be added here, and the relationship. So that's something we would like to have discussion with the working group during this week. And also maybe after this IETF, we plan to schedule a couple of calls. Whoever is interested in raising opinion, views. So we would like to really have this converged very quickly, so that by next IETF, we would like to have a mature draft that we may only manicure, get reviews on, and process quickly towards official reviews, working group last call, etc. So here, as you see, we currently have 4 elements defined: traffic as an anchor point, the traffic ID, and it connects basically path and user plane anchors. So there's a path identifier and user plane anchor ID. And as you see, a particular traffic can be aggregated traffic for one user equipment or on a flow basis. So here the info model just refers to traffic descriptor. Optionally, it may also hold information about session descriptors. So if we want to apply that to other drafts in this working group, like MOP, there is an interface that retrieves session information from a mobile communication system and transfers that into routing information. So if session descriptors multiple times. So a list of attributes. In a table model, this is easy. There is an agreed notation. So here we said, so the path can be a single data plane node, which is maybe the next hop, or a segment of data plane nodes. So if it's a data plane node identified as a node, or if it's a hop ID, that could be a segment ID. So here the model wants to be flexible enough. And then for every hop or node, then the DPNs are being described with the hop ID being supported. And also we consider DPN nodes, which are ephemeral. Either they move or they enter power save mode. So that is also a reason to steer the traffic between the mobile communication system and the data network. So this is starting point to discuss and converge on the information model, which when it's mature, hopefully soon enough, then we will add a proper table representation in the ID. Covering that kind of pictures in a draft with ASCII is a little bit difficult, but as a working document to discuss with interested people, it's I think the right approach. Yeah. So we would like to get your opinion here, and I think that's the last slide of the presentation. Either you have an immediate comment, question, input regarding the information model. If you're interested in joining the discussion on progressing this, please let me know. Just send me an email. We'll also send out some proposals for calls in the next weeks. And second, yeah, the question before, I mean, we asked also some 3GPP delegates because it applies, and some of the authors also contribute to 3GPP in the view of next generation evolution. So there is relevance of these use cases and associated ideas in the evolution of 3GPP. So if you have an opinion now, maybe you can provide it as feedback already. I think we
So
have.
Marco, if I may ask a simple question.
Sure.
Topological identifier, what exactly you plan to keep there in the topological versus UPA UPA topological locator versus geographic locator? Geographic I understood, but topological locator, what exactly you plan to keep hold?
Well, if we have data plane nodes or user plane anchors on nodes that move, so they may change in terms of their geographic location, that's clear, but also in terms of their topological location. If they are treated as a router and they move, so the routing system is something more agile. So the peers that connect to each other, the routing tables, they change. So that's
No, I guess my question is, what is the data type actually? So what do you plan to? Yeah.
Well, this is an information model. So what is the data type here that we currently leave open? Also, we have a reference or an information regarding supplementary information. So if there is any service that can provide more information on the topology, on the agility, how that topology or geographic location changes, which is, for example, important for satellites that are not stationary but move. So here we just provide a pointer to retrieve such information without going into details here. But
So it's abstract. Okay.
if I hope it makes sense. I mean, that's the points that we want to discuss, right? If people see that relevant in the information model. But please start looking at the use cases, because we should not think only about use cases from 4th generation, 5th generation, but a little bit more into the agility that will expect us in the future generations. Here, look at the use cases, think about the description here, and then we should nail down an appropriate information model. Is it a bit clearer, Sri?
Okay, thank you, Marco. Is that your last slide, Marco? Or,
That's it. I think so. There is an appendix. Yeah, that's the last slide. The one before, we just have the plan presented, and that includes discussion on the 3GPP aspects. If you don't want to have an opinion now, please let us know by email.
yeah, we can ask any questions, comments on this presentation.
Yeah.
Looks like John has a comment.
A few questions for clarification,
Sure.
actually. No, not. So I wrote down a few things. So, I'm also participating in the 3GPP side on the user plane. So from that point of view, flexibility and reselection, so in a session, there may be multiple flows. And if you're going to reselect these data plane nodes, what is in which flow are you going to prioritize in terms of taking that decision to relocate or reallocate more flexibly? I'm assuming that one
Mm.
flow may go to one data center, let's say, or another one to some other place. So how are you going to manage this?
So
Or what are the principles around that?
the
That's one.
principle and the use case behind is that a mobile user may have one or multiple user plane anchors associated, right? Though one flow traverses only one dedicated user plane anchor, either identified by the user IP address or other means. So the rationale behind is if the user plane anchor changes, that it's not a decision from the transport network or the data network, but the mobile communication system takes that decision, right? But it needs to notify towards the transport network. So if the user plane anchor changes, you don't want to have, let's say, remaining flow anchored at the previous anchor. But in terms of optimized routing, you need to steer the traffic to the newly selected and serving user plane anchor. So this is notified through the API that we specify here, and transport network adjusts the flow.
I think that's an assumption you're making, and it should be sort of made explicit in the draft, because you could
Okay.
have more than one flow
Yes.
with not exactly the same destination, or even, I mean, there are different models. It's not clear yet what's going to happen, especially going forward.
Well,
But
the granularity about the traffic descriptor, we leave it open here. So we may have one flow, particular flow,
Mhm.
being assigned to one particular user plane anchor and a path towards one data network, and another flow of the same mobile user through another user plane anchor, or the same user plane anchor to another data network.
Okay,
Right?
so those assumptions
Yeah.
would be good to clarify, because I think
Let's
it's
maybe
essential.
look together at the use
Yeah.
cases
Okay.
because they are clear about that.
Okay.
Right?
A second question also, I mean, and we can discuss after.
Yes.
So second one is about, how does this impact flows above? Because if you reselect, So let's just give it a few minutes. The chairs are suggesting that we wait for maybe 5 or
We
so.
can hear you, John. At least the audio is working now.
Okay, Shri, that's great.
Okay, but the video we can't see anything in the room, but it's fine, I guess. Yeah. Okay. Yeah, it's coming up. Something. Yeah.
Yeah, if you can share the slides for us, that or
Okay. Yeah. It's on back. Satoru-san, are you back?
he doesn't seem to be on. But
Okay. So, John, next, you want to go next, or is it your slides?
yeah, I can go next. However you like. I mean,
You
however.
want me to? You can share, or you want me? It's better if you share. You
I
can.
don't think I can. You know,
Okay.
because
Let me share. Then don't worry. Yeah. John, you uploaded the slides to the. All right. I think how come
yes,
I don't.
yes, it's under the Yang model. It's the last one in the list.
Yang data model, right? Yeah.
That's right.
Okay.
Sorry, I'm back now.
Yeah. No, it's Satoru-san. Thank you.
So thank you, Sri and Satoru. So this is a Yang data model for attachment circuit as a service with UDP support, tunnel support. The next slide, please.
Oh, sorry.
Okay. Just as a refresher, this has been looked at in the context of two documents this working group has been working on. One of which is already in working group process already. That's the TN aware mobility. And this draft with the ACAS side was split out because the data models are the Yang model with the UDP and ACAS is independent to an extent. I mean, it is not necessarily tied only to the TN aware mobility mechanisms and can be used generally anywhere else. So hence we have this two drafts, one that's more of a informational draft that discusses all of the way it can be used in a 3GPP network. But in general, this particular one with the Yang model is only describing a bearer, ACAS bearer, a connectivity, circuit bearer, UDP bearer. So that's the context in which we're looking at. So this figure here is just showing how this was split, because I see there are lots of newer people here. Just to let you know, this is how this draft is split up. Okay, so next slide, and I can go over very briefly what we've changed. So the next couple of slides are just going to talk about what this UDP model is conveying. As a context, the current uh, the the this is an extension of the Yang models that are already there with the AC models, and that's already um, a
John,
okay.
please keep going.
Okay,
I
sorry.
just issued the.
I think we can see the polling more or less, but that's okay. Um, yeah, so this is a Yang model extension because the previous attachment circuit models considered layer 2. So basically VLAN and so on. What we're doing here is simply extending it to a layer 3 bearer, a UDP bearer, and the attachment models for that. So this has been reviewed by multiple people who have forgotten to acknowledge also, and I apologize for that. But there has been some really serious reviews on this draft. The model that's the Yang model has been validated, and it's current, and so I think there's a fair amount of confidence that it represents a model that can be generally used beyond the scope of just this one slicing draft. So that's the aim with which we're working on this draft. I think that's a very high level summary of where we are on this. So just as I mean, I have another slide which put together the comments that I got during the working group adoption call. All of these comments are pretty straightforward to address. So I think in the next revision, we can clearly make those changes. You know, some of it may require some discussion on the working group list, but otherwise they're very straightforward, and we can address that and go forward. So that's where we are at. I don't think we need to look through the rest of the slides. I mean, this has been looked at several times. So appreciate any comments if you have, or otherwise we can. And that's all I have to.
Okay, any questions, comments? I see Lionel.
Yeah, thank you. Good morning. Yeah, actually we can, so from my understanding, what we have done already in the previous draft was just so I still don't understand why, but based on the feedback that we have received, it was necessary to split. But from my point of view, what we have so far is exactly what we had in the working group document that was already ready for publication. So I think it's straightforward to, so of course people are invited to review it, but I think that the content so far in the description of the young model is according to what we have done since more than 1 year now, and I think it's okay to adopt it, and even as soon as it is adopted, to move it forward for working group last call and so on. So there is no specific reason to delay this process because what we are doing here is just administrative work initiated by someone else, saying that from my point of view, it was not needed at all, but actually we are just following the guidelines provided by the reviewers and so on. So, but just to say that okay to adopt it and even to push it forward as soon as it is adopted.
Thanks, Lionel. My sentiments. I'm glad to hear the feedback from others.
Thank you,
Thank you,
Lionel.
Leonard. So
Sorry,
from my side, just to reinforce that I agree with Leonel. There's no reason to split from the TN mobility draft, but Ops AD requested, so unfortunately the young model be separated, but there's no reason to argue that the adoption and working group last call. That's it. Thank you, John.
Thank you.
Thank you, John. Any other questions, comments? Okay, if not, thanks, John. Yeah.
I'll remind the chairs that
Please.
you have the unilateral ability to declare a document adopted. You don't even need to have an adoption call. You can just proceed straight to adoption, and then we'll go from there.
I can see I can see the enough portion of the hands to yes for adoption. I think we have agreement for the adoption.
Satar-san, Eric is saying we don't even know how to run this, but I guess it's up to you. Yeah, it's totally fine. Yes. Thank you.
Yeah, chairs can just unilaterally declare a document adopted.
Okay.
So
Okay, given that
secret chair power.
I see. Okay. Okay.
Yes.
All right. Thank you, Eric. While you're on that, the other document, it's in your. Tommy is going to take care of this, or have you guys decided? Or
yeah, it's on me to do kind of an AD eval, but then just hand that off to Tommy as a guide for him to get started.
All right.
Yeah, that's gonna probably have to wait till the end of this week though.
Sure. Thank you. Okay, so I guess we'll wait for Tommy's and your reviews, and we'll go from there. Thank you so much. And I think yeah, all right, we can close this deck here. Next. I think we'll go with the how from Singapore University Mobility Management for International Sharing in LEO satellite networks. Anand, are you at the room?
Yeah,
Okay, good to
Sri,
see
just
you.
1 second. One question. Will you be controlling the slides for this, or?
Yes, I'm sharing the slides. I'll control you. Yeah. Just let me know when to move forward. Yeah.
Okay. Good morning, everyone. I am Yunan Ho from Tsinghua University. Today, I will talk about our work on mobility management for inter-SNO sharing in LEO satellite networks. This work studies a new trend in LEO networks, where different satellite network operators will work together and share infrastructure. This can help deployment, but it also brings new mobility problems. In this talk, I will first introduce the background, then explain the main challenge, and finally present our solution.
Okay. You can.
Next slide. Next slide. Here is the outline of my talk. First, I will briefly introduce the LEO networks and satellite network operators, or SNOs. Then, I will talk about satellite mobility and handover. After that, I will explain inter-SNO collaboration and the challenges and LEO mobility. Finally, I will present our mobility management solution and give a short conclusion. Next slide. Next slide. This slide shows a typical LEO network architecture operated by one satellite network operator. In this architecture, users connect to the internet through satellites and ground stations. The traffic then goes through the SNO core network, which provides functions such as authentication, accounting, and IP address management. For example, in this figure, a user connects to a ground station through one or more satellites. Then the ground station connects to the SNO core network, and after core functions like authentication, accounting, and IP address management, the user can access the internet. A key point here is that all satellites and the ground stations belong to one operator, and the users access network services through that operator's full system. So, in this typical architecture, the LEO access network and the core network are tightly connected to one single SNO. Next slide. Next. One important feature of LEO satellites is that they fly at extremely high speed because of their low orbit altitude. Because the satellites move so fast, a user terminal or a ground station cannot stay connected to the same satellite for a long time. So they have to switch from one satellite to another again and again. For example, in this picture, the satellites moved quickly from left to right. When one connected satellite moves out of the visible range of the user terminal or ground station, they switch to a new satellite that is coming into view. This process is called handover. That means mobility is not a rare event in LEO networks. It is a basic and continuous feature. Next slide. Next. Meanwhile, because the LEO satellites move so fast, we need a very large very large number of satellites to provide continuous global service. This is why mega constellations like Starlink, Amazon LEO, and Telesat all plan or deploy thousands of satellites. For example, in their earlier plans, Starlink wanted to launch more than 4,400 satellites. Amazon LEO wanted to launch more than 3,200 satellites, and Telesat wanted to launch more than 1,600 satellites, so they could provide global coverage. So, the first message of this slide is high mobility leads to large constellation size, and the second message is building and operating such a huge constellation is very expensive for an operator. This also gives us a reason to think about cooperation between different operators. Next slide. Deploying so many satellites is complex, time-consuming, and costly for one operator alone. So now there is a trend toward inter-ethno collaboration. That means different ethnos may share infrastructure to speed up deployment and improve service coverage. This figure gives a simple example. In the early deployment stage, the number of satellites is still small, so it is hard for one SNO to provide continuous global coverage. Taking North America as an example, if Amazon Leo works alone, its coverage is limited. If Telesat works alone, its coverage is also limited. But if they collaborate, the overall coverage can become better, as shown in Fig C. So inter-ethno collaboration can bring clear benefits. Next slide. But under LEO mobility, it also creates new challenges. The main problem is that LEO mobility can frequently trigger inter-ethno handovers. This is different from normal handover inside one operator's network. In an inter-ethno handover, the user may move from the service of one ethno to another ethno. That means the handover is no longer only a link level issue. It also needs coordination between different ethno core networks. For example, in the left picture, at first, the user is connected to a satellite of SNOA and accesses to the internet through the core of network of SNOA. But as satellites move very fast, after some time, that satellite moves away and a satellite of SNOB comes into view. Then the user connects to the satellite of SNOB and accesses the internet through the core network of SNOB. At this point, the core network is also changed, which can lead to network disruption. If this happens too often, the seamless service becomes very difficult. As shown in the red figure, in major cities around the world, users may experience about 20 to 80 inter-ethno handovers per hour. So this is a very serious mobility management problems. Next slide. To address this problem, we propose a new mobility management solution with two core components. The first component is shared LEO access. The second component is independent ethno core networks. On top of this architecture, we design a tunneling-based mechanism to support flexible and dynamic satellite ethno association. In simple words, within our architecture, this means a satellite is not fixed to only one operator all the time. Instead, it can be associated with different ethno core networks in a flexible way. Next slide. Now, let me explain this architecture a bit more. First, satellites are decoupled from individual ethnos through shared LEO access. This means the satellite access part can be shared among operators. Second, the ethno core networks remain independent. This is important because each operator still wants to keep its own core functions. So our design tries to balance two goals. On one hand, we want to sharing and flexibility. On the other hand, we still want each ethno to keep control of its own core network. Next slide. Based on this architecture, each satellite can be dynamically associated with different ethno core networks, and different ethno core networks can communicate through tunnels. This tunneling support is very important. It makes dynamic satellite SNO association possible in practice. So, even if a user is served through a shared access network, the traffic can still be delivered to the correct SNO core network. In this way, the system can adjust satellite SNO association according to mobility and service needs, instead of using a fixed banding. Next slide. Now, let's talk about the mitigating the impact of inter-SNO handovers. Our first goal is to reduce the number of inter-SNO handovers as much as possible. The key idea is to make smart satellite SNO assignment. We use 3 pieces of information. First, satellite trajectories are predictable. Second, we know the existing user SNO associations. Thirdly, based on this, we can assign satellites to suitable SNOs to reduce users' inter-SNO handovers. If we can avoid unnecessary inter-SNO handovers in advance, seamless service will be much easier to support. Next slide. However, not all inter-SNO handovers can be avoided. So, our second goal is to make an avoidable handover faster. The left is the baseline handover process, RFC 6275, mobility support in IPv6. Needs several steps after the new link is formed, such as call discovery, authentication, and tunnel setup. These steps increase disruption time. Our idea is proactive switching. Using pre-computed satellite SNO associations, we can prepare some operations earlier before the handover fully happens. For example, we can do a proactive authentication and proactive tunneling. As a result, when the actual handover happens, the process becomes shorter and the service disruption time can be reduced. So, the key message of this slide is: first, reduce the number of inter-SNO handovers. Second, when they cannot be avoided, shorten their interruption time. Next slide. To conclude, LEO mobility makes inter-SNO collaboration both necessary and challenging. To support this new trend, we propose an architecture with shared LEO access, independent SNO core networks, and flexible satellite SNO association. Our solution works in 2 ways. First, it reduces the number of inter-SNO handovers through trajectory-aware satellite SNO assignment. Second, for unavoidable handovers, it uses proactive faceting switching to shorten service disruption. Next slide. Thank you all.
Thank you, Iran. Any questions, comments from the room? I don't see anyone on the. I see John. Yeah. John, and after that, Lionel.
So thank you for the presentation. Just a few comments.
Okay.
So one is that the point of presence to the internet you show is the same for both of the independent satellite networks.
Yeah.
So I think that's a big assumption. I mean, usually there would be different points of presence to the internet, right? So meaning that the router that connects to the internet from SNO1 is different from the point of presence for internet 2, I mean SNO2. So that could have some implications on the architecture. It may be something to look at. Okay, I can talk to you offline also. So that's one of my comments. Another comment is that, you make an analogy between or the motivation for this is collaboration to reduce infrastructure cost and comparison to an MNO. In the MNO case, there is no inter-operator handover during a session, at least as far as I can see. So that's another big assumption you're making. So in the flows that you show, you do all of the proactive authentication, all of that, but that's also a big assumption that you have to think about how that goes. So there are some architectural impacts on that. It's quite different from the MNO use case, I would say.
Real world use cases.
Like from the mobile network use case, mobile network operator use case.
Yes.
So you can attach to to one network, but in between the session, it's not handing over to another network, another operator.
Yes.
But in this case, you're handing over between operators. That requires some thinking. I think maybe you need to add a little more detail in the draft regarding to that.
In the Leo networks, it has a fundamental different to the traditional mobile networks.
Yeah. Okay.
The Leo network fundamental difference comes from the Leo satellites flies very speed, about 6 kilometers per second. So the user terminal have to first switch between among different satellites, but in traditional mobile network, a user when a user leave when the user leave on a base station of a operator and they access to another operator base station, they will switch the operator is roaming. In the Leo network, is similarly roaming, but this roaming is enforced, is passive.
Right. So that's what I'm saying. If you take that and the fact that the termination points, the point of presence or the exit to the LAN network, they're also going to be different. So something to look at. We can talk offline.
Okay, thank you, John. Lionel?
Thanks.
No, it's yeah. There are more questions. Please stay there. Yeah,
Quick question for you.
yeah,
Or at
yeah.
least
Please.
thank you. So thank you for your presentation.
Mm-mm.
I think that before jumping to the solution space, as said by John, there is maybe some working assumptions that need to be first validated. Looking at the use cases for user trying to use satellite services, especially the need for inter-SNO, because actually you said that you may have multiple SNOs that cooperate, which is true, but in that case, like in mobile network, if you have a shared access network, from the user point of view, it will be only one SNO. So so the SNO will manage to provide the same access to the ground floor or even on the POP behind. So in that case, you don't have this kind of handover from the IP level point of view. So you will switch from one satellite to another satellite, satellite to satellite. I don't know how to say it, but you will not change your IP address. We have the same case for mobile network when you have a shared access network. So I think this kind of working assumptions need to be evaluated and to see if there is a real need for an handover at the IP layer between these satellite networks. But we can talk about this after the session if you want. Okay.
Thank you, Lionel. Sadara-san?
Thank you. Thank you for your presentation. I think this is interesting. Sorry, keep stand on mic. Thank you. Thank you for your presentation. Can you hear me?
Hello.
Yeah, we can hear you, Satoru-san. Yeah.
Okay. From my side, it'd be question or comment. So, as you presented, the anti-CNO make certain level of the cost saving. So, how much of the cost be saved? Could be my question. Did you have such simulation or estimate the cost to be saved?
Yes. In the real world, the Starlink has launched more than 9,000 satellites. But in our simulation, we find that when Amazon Leo and Telesat collaborative, they can only launch the 40% satellites. 40% satellites it can do the similar 这个 coverage with the now Starlink. Only from the coverage perspective.
You mean 40% be satellite be reduced? Is that correct? If the inter SNO be achieved.
Pardon?
I think you said the 40% satellite be reduced if the inter SNO be deployed.
Yeah. With the
Okay.
Amazon Leo and the Telesat, they all launched the total number of their planned satellites. 40% satellites. When the Amazon Leo and Telesat Leo, their total satellite is about 3,000 and 1,600 satellites. So about percent of 40% of 4,000 satellites is enough to cover the global Earth.
Okay. Have you simulate the exact cost simulation? For example, how much money, how much the dollar, how much of the renminbi be saved by inter SNO operation?
The economic issues and the security issues in current we don't care them. In the future work we will consider the economic and the security. Now we only focus on the performance.
Okay, so I think it would be very good to do in the future to convince the industry how much it costs, how the security should be solved by inter-SNO. Thank you very much.
Okay.
So thank you. Any other questions, comments? Good presentation. I'm glad you guys are doing this in university. Great stuff. So I think as John, Lionel, and others advised, right? I think you may want to focus on the problem statement more than instead of quickly jumping into the solution and call flows, right? Even if you can document your observations, whatever you're doing simulations, like I think the how you can optimize the network or whatever, right? By interest handoffs, right? I think whatever. I think just as a documenting a problem statement itself might be good first step in my opinion. But this is definitely good work. Looks promising. Yeah, please keep us updated on the group. What you guys are doing next. Thank you, Inan. We can't hear you, John. We lost the audio. Okay,
No,
now
I
hear
think
you.
you can hear. Okay, I was just
Okay,
conveying.
okay. Um, that's Satoru-san. You have any next topic? You want to discuss anything?
No, I will send the mail to confirm the adoption call will be success in the mailing list for the
Okay.
John draft.
Thank you.
Okay. Any other questions, comments from the room, John, that you see?
Don't see any. Maybe I'll ask again. And if anyone has comments on any of the topics. No, none that I can see.
Okay, before I think that's our last topic. As far as I know, there's no other. Anything from the ADs, Eric or Tommy?
About this specific presentation, or
No, in general. In general.
in
Anything?
general?
Okay, we are almost.
no.
This is the last topic here.
I would just say, well, at some point, thank you for bearing with me for 6 years. It's been interesting. I'll leave you in Tommy's hands.
Yeah, maybe we should, Eric. Maybe we should tell the group that, right? I think uh, Eric is stepping down as AD after a long time. He has done some excellent work. We want to thank Eric from everyone. Thank you so much, Eric.
It's been my pleasure to try, and thank you everyone for bearing with me for it took a long time to do some things. I appreciate everyone's support.
Yeah, and Tommy. Yeah, sorry. Go ahead, Eric. Please.
I was going to say, we've had a chance to sync with Tommy, and he's coming up to speed on all things DMM.
Eric, once again, greatly appreciated. Tommy, you want to say a few words, introduce yourself? I think that would be great.
Certainly. Hello, everyone. I'm Tommy Jensen. I'm stepping up this Wednesday as your new responsible AD. I've been in the IETF for a few years. My background is from the DNS areas and first intersecting with the 3GPP world when doing IPv6 stuff and making the brazen assumption that router advertisements are ubiquitous everywhere. Been learning a lot about how cellular networks work since then. So I'm looking forward to supporting you in everything you're doing, which for the most part ought to be staying out of the way and making sure that everyone else stays out of your way.
Thank you very much, Tommy. We look forward to working with you. Once again, John, thank you for hosting the meeting locally. We greatly appreciate it. With that, we wrap up this meeting, short meeting this time. But thanks everyone. Yeah. Thank you, Satoru-san. Thank you, Eric. Thank you.
Thank you, John. Thank you, Suri-san. Thank you, Eric. Thank you, Jimmy.
And thanks to Louis for the notes.
Yes, please. Thank you.
Please. Yeah. Okay.
To see you in Vienna.
Okay, well, see you all. Thanks, Satoru-san, and meeting's closed.
I was also working in another draft, commented with a colleague of mine from Nokia. So we had the idea maybe to combine together the ideas, and I think we discussed in the past.